Hello, and today's learning target is I can divide monomials. So similar to multiplying monomials, we can also divide monomials, and we will break this lesson up into two different days. And if you're thinking ahead, when we were multiplying monomials, we added the exponents of the same base, so variables that were the same, we were able to add the exponents when we were multiplying. So now when we divide, we will do something similar, but we will subtract the exponents subtract exponents with the same base or having the same variable. So the first thing we're going to look at, the first rule, is called the quotient of powers rule, and this is the division of two monomials. So if we look at the first example, I'm going to look at actually r to the fifth over r squared, because that will be a little bit easier to write this first example out. So if I have r to the fifth over r squared, I can write that out as 5r's over 2r's. And then if I have two r's on the bottom, those 2r's will cancel with 2 on the top, and I'm left with r cubed. So I could have just taken, r to the fifth and subtracted 2 from 5 and get r to the third as well. So this is just a visual here of what this represents, r to the fifth over r squared. However, if we know the quotient of powers rule, simply exponents with the same base, and the same base here is r, means we really can subtract the exponents. Okay, c to the 11th over c to the 8th. 11 minus 8 is 3. So this answer would be c to the third. Okay, directly below that one, g to the third, h to the fifth. All over gh squared. So if we look at the g variables, g to the third over g would be, if I just, even cross one out right there, cross 1 out of 3, I get 2, right? So I can subtract or simply, do some crossing out to kind of see what happens. If I take away 2 h's, take away 2 from 5, I get 3. So g squared, h cubed. Okay, this last one, k to the 7th over k to the 5th, if I take away 5 from the bottom, I'm left with 2 on top. M to the third, take away 3 from 10 and get 7. And then p to the first over p to the first, those will cancel out. So I will just get k squared m to the 7th. Okay, and again, more to come on quotient of powers rule. We'll see in our next video. We'll add on to that a little bit. All right, now we're going to look at power of a quotient. So the division of a monomial raised to a power. So here in this first example, x over t to the fourth, I'm going to, I see parentheses and then a number, right, but this is to an exponent similar to the distributive property. So I'm going to distribute that 4 to every term inside the parentheses. So x really to the first power times 1 times 4 is 4. T to the first power times 4 is t to the fourth. So I have x to the fourth over t to the fourth, and those are not the same base. X and t are different variables, so I'm not allowed to simplify with their exponents at all, and that would be my final answer. This next example, r over t, all to the third power, I'm again going to distribute that 3 and get r to the third over t to the third. Again, I would look to simplify when I'm done, but r and t are different bases, meaning that they're different, so I'm not allowed to cancel out any terms, or any exponents for that matter. All right, in this example here, 3x to the fourth all over 4, all to the third power. Again, I'm going to go ahead and distribute, and I get 3 to the third power, x to the 12th, because 4 times 3 is 12, all over 4 to the third power. Now I'm going to take this a step further, and I will go ahead and I will say what 3 to the third power is and 4 to the third power is. So 3 to the third power is 3 times 3, which is 9, times 3, which is 27, x to the 12th, all over 4 to the third power. 4 times 4 is 16, times 4 is 64. And so that would be my final answer for that third example. So again, simplifying when we can, 3 to the third and 4 to the third, we'll write down as what that value is. All right, last example, I'll distribute this 2 to everything. Again, I like to draw lines, meaning representing arrows, that I'm distributing that number to every term. If you don't like to do that, that's not a problem. It just helps to remember what I'm distributing that 2 to. So I have 2 to the second power, y to the fourth power, all over 3 squared, z to the sixth. And again, I multiply my exponents when it's power to a power here. And 2 to the fourth, 2 to the second is 4. Y to the fourth, all over 3 squared is 9. Z to the sixth. And I can't simplify because 4 over 9 is a fraction that can't be simplified any lower. And y and z are not the same bases, so I cannot simplify any of those exponents there. So that would be fully simplified. Okay, now let's look at simplifying the following expressions and putting all of the rules that we've learned together so far. So let's zoom in a little bit here. So with this first example, I'm actually going to cross out the j to the negative third. I don't want that in there right now. Okay, so I have 25 k to the second, m to the sixth, all over 5k to the negative fourth, m squared. I want to get rid of that j to the negative third because we're going to deal with more negatives tomorrow. However, we can do a little bit of that rule here today in this video. So 25 over 5, let's break it up there. 25 over 5, just the numbers. That will simplify to 5, right? Okay, now I have k squared over k to the negative fourth. Again, I subtract exponents. So if I have 2 minus negative 4, again, when I divide, exponents with the same base, I subtract their exponents. So 2 minus negative 4, chop chop is really plus, I get k to the sixth. Now I have m to the sixth over m squared. Again, I subtract, or if I take away 2 there, I'm left with 4 in the numerator. So 5, k to the sixth, m to the fourth. That would be my final answer. Okay? All right, let's look over here. T to the fifth, u to the fourth, all over t squared, u to the third. So if I, again, break this up, and I say t to the fifth over t squared, if I take away 2 on the bottom, I'm left with 3 on the top. So t to the third would be my ending result there. U to the fourth over u to the third. If I take away 3 u's on the bottom, I'm left with 1 on top, so u to the first. And if I wanted to write, my final answer without that u to the first, I can, and I can just put u, and that's actually the proper way to write it. You don't necessarily need to write in the 1 for the exponent there. And that would be the simplified answer. All right, let's continue on. All right, now I have to distribute before I can look at simplifying. So if I distribute this squared here to everything, I get 2 squared g to the sixth, h to the fourth, and then over, if I distribute the 3 to everything, g to the sixth, and then h to the 0 times 3, 0 times 3 is just 0, so h to the 0 power. All right, let's simplify this a little bit further. 2 squared is 4, and then I have over 1, right? So here, 4 over 1. G to the sixth over g to the sixth, sixth, and then h to the fourth over h to the 0 power. All right, and now I'll end up with 4, g to the sixth and g to the sixth, g to go away, right? 6 minus 6 is 0, and then h to the fourth over h to the 0 power. 4 minus 0 is 0, so 4h to the fourth would be my final answer. In our next video, we will also talk about anything to the 0 power, and anything to the 0 power is actually just 1, so it's like a wash. So we'll go over that again tomorrow, but if you type in something in your calculator, 4 to the 0 power, you'll get 1. So any variable to the 0 power will also be 1, but more to come on that. All right, last example here. Okay, so I'm going to first start by distributing this exponent to everything inside the parentheses. Draw my arrows, right? It helps me remember. And I get 2 squared, a to the negative fourth, b to the eighth, c to the fourth, all over negative 4 squared, a to the negative fourth, b to the negative 10th, and c to the negative 14th. Okay, so I have 2 squared, which is 4, okay, over negative 4 squared. So negative 4 times negative 4 is is positive 16. So I know I'll eventually simplify that. Okay, I have a to the negative fourth over a to the negative fourth. So if I have a to the negative fourth minus negative 4, chop, chop, plus, negative 4 plus 4 is actually 0, so those will cancel out. Okay, I have b to the 8th and b to the negative 10th, right? So b to the 8th, so I have 8 minus negative 10, chop, chop, plus, means that I will really have 18 here in the numerator, on the top. Okay, c to the 4th over c to the negative 14th, I will have here 4 minus negative 14, chop, chop, plus, so this really 4 turns into an 18. Okay, so I have 4 over 16, I'll simplify that, take out a 4, that turns to a 1, 16 turns to a 4. Okay, so let's rewrite this, 1 over 4. Okay, I had no a's, right, those canceled out. I have b to the 18th on top, and I have c to the 18th on top. So I could even write this a better way. I don't necessarily need to write that 1, and I could say b to the 18th times c to the 18th all over 4 would be my final answer. So there's a lot of rules that go into monomials, but if you break it down, write everything out, show your work, you'll be just fine. Thanks for listening. Have a great day. Bye-bye.